Hey there guys, Paul here. In this video, I'm going to be walking you through some examples for the selection of valves in a hot gas defrost line for an industrial refrigeration application. Coming up, selecting valves for the main gas hot defrost line, selecting valves for the hot gas defrost line, selecting valves for the defrost drain line, as well as generating a report. This video is part of a series where we'll be looking at a number of worked examples using the Coolselector 2 application to help you select and calculate components for your refrigeration system. So do check out the other videos if you haven't already. Links are in the video description below. As this is an industrial application, we'll change our preferences to show the most relevant products. To do this, simply click on Options in the top menu bar and then click on Preferences and then select Industrial Applications. We start the selection process for a valve in the hot gas defrost line by first clicking on the Components and Series tab. The screen will then refresh for a number of system schematics. For this example, we'll go to the hot gas defrost pump system. We can then select which section of the system we're calculating. First, we'll choose the main hot defrost line. This is the common line shared by the evaporators from the compressor discharge line. We begin from the top left-hand panel by first selecting the refrigerant being used. In this case, we'll be using ammonia. We then have the option to choose a connection type, but for this case, we'll leave this as all. We now need to define the operating conditions. For this example, we have 10 evaporators in our system, each of them rated at 80 kilowatts. Our system is designed to defrost 3 evaporators simultaneously. Since this line is shared between the evaporators which are at defrost at the same time, 80 kilowatts multiplied by 3 gives us a capacity of 240 kilowatts. So we input that first. We will then input an evaporation temperature of -20 degrees Celsius and a condensation temperature of 30 degrees Celsius, with a circulation rate of 3. Then we need to enter the hot gas defrost inputs. First, we need the defrost capacity factor. This defines the mass flow rate in the line based on the cooling capacity of the evaporator and other defrost parameters. Then we need to specify the main hot gas supply temperature, which can be at the discharge temperature, but is usually reduced to the heat loss in the discharge line. The next input is the reduced hot gas supply temperature. This is the dew point saturation temperature of the hot gas provided at the inlet of the evaporator's individual hot gas defrost line or the pressure. Then we have the defrost dew point temperature or pressure, and then the dimensioning quality. For a more detailed explanation of the hot gas defrost inputs and selections, you can use the help button provided here. Here you have the required information explained on the diagrams and a more detailed explanation provided in this PDF document. Now we should add the preferred products to the line. On the left-hand panel, we have the product selection. Here we can choose which components we require in our main hot gas defrost line. For this example, we want to first add an ICS plus CVC valve. So we click on the Control and Regulating Valves. We then see a list of available products will load in the Product Family section. We can hover our mouse over the titles of these products to display a small photo and a brief description of the product. We want to add an ICS plus CVC valve to our line. So we can either drag and drop that from the list or simply double-click the title. We can now notice that the valve is added to the line with a green line at the top, which means the selected product is suggested by Coolselector 2. If we now click on the valve symbol, a pop-up window will appear. There you will see the product highlighted with a green row. If we select another product from the list, we can notice that the green line would disappear. We'll go back and select the product from the green row again. This is the suggested product based on our inputs. This is only a suggestion and you should check the performance details to decide if this is best for your system. Let's now add some pipework after the valve. We can do that by clicking on the piping icon in the product sections. We see the available options load again in the product family section. For this example, we'll choose steel DIN EN pipe and add this to our line by double-clicking on the title. Notice that Coolselector 2 has automatically added an expander between the valve and the pipe, since the suggested pipe size did not match the valve size based on the default selection criteria. Notice that there is a blue line at the top of the expanders and reducers. This line specifies that the selection is up to the user. To see more information about the lines on top of the products, simply hold your mouse over the top bar of the product icon. Looking at the pipe information in our diagram, the length has defaulted to 10 meters. We can click the value and change this to our needs. In this example, we'll input 150 meters. The capacity of the valve is sensitive to pressure drop before and after the valve. As you can see, the green line has now disappeared from the top of the selected valve. This shows that the selected valve is not the suggested one anymore. We can change the valve by clicking on the valve icon and choose the suggested one. Now, as you can see, the expander has a connection problem as the selected valve is larger than the expander. To fix this, we can click on the expander and then select the proper expander in the list. Therefore, it is always important to add all the pipes and fittings with the correct values for dimensions, length and angle, and then reconsider if the selected valves satisfy our requirements considering the piping. In the lowest section of the screen, we have the Performance section. Within the Performance Curve tab, we find an interactive graph plotting the collective effect of the components in the line on capacity against the mass flow rate. We can also see the individual component curves in the following tabs, which plots the variations in each component based on the capacity. Under the Performance Details tab, we can find the thermodynamic data for the system, along with a system schematic and a pressure enthalpy chart. In the subtabs, we find further information and thermodynamic data for the system as a whole or the individual components. Now we would like to add a solenoid valve in the individual hot gas defrost lines to enable start-stop of each evaporator defrost. To do that, we open a new tab, and from the Components in Series tab, we select the hot gas defrost line from the pump schematic. We can notice that Coolselector 2 kept our inputs from the previous selection. We just need to change the cooling capacity to 80 kilowatts, as this is the selection for a single evaporator. We'll then add an ICS-H solenoid valve to the line. ICS-H valves are specifically designed for two-step hot gas injection into the evaporator, which is a soft opening valve to increase safety in the system. Similar to the previous example, you can see the green line on the top of the selected valve in the line. If necessary, you can add the required piping to the line and then see the impact of the piping on the system, and also the individual performance curves and details in the bottom section of the page. Now we want to select the valves for the defrost drain line of the evaporator. There are two typical solutions using the drain line. A control valve keeping the defrost pressure constant, which is called the pressure control drain, and a float valve which simply lets condensed liquid generated during defrost back into the separator. This is called a liquid drain. In this example, we want to select an ICF with a float expansion valve for our defrost drain line. Similar to the previous selections, we add a new tab, and then under Components in Series, we select the hot gas defrost drain line in the pump system. We can see that Coolselector 2 kept all the information from our previous selection, and we just need to add the necessary valve to the line. We can add an ICF valve by selecting ICF valve station in the product section, and then choose one from the provided options to add to the line. As you can notice, there is a blue line on top of the ICF. This is because the selection of an ICF valve station is up to you based on your requirements in the system and specific functionalities you may need. The selection of valves for an individual evaporator in the hot gas defrost line and the defrost drain line can be done simultaneously using the evaporator valve station wizard in the Industrial Applications tab, which we discussed in a separate Coolselector 2 video. We can generate a report for our selected product simply by clicking on the Report button in the top menu bar. The window will then refresh to display our product report. In the left-hand panel, under Items to include in the report, we can also add or remove information from our report by clicking on the plus button and then selecting or unselecting the item. If we make a change here, then simply click the Update button at the top to apply these changes. Additionally, we have the option to add a project name, some comments, as well as an author name to the report using the inputs at the top of the left-hand panel. Again, if you make a change here, then simply click the Update button to apply these. Along the top of the report, we also have various options to export the report. Okay, that's it for this video. Thank you very much for watching. We hope you enjoy this and it has helped you. If so, please don't forget to like, subscribe and share. If you have any questions at all, let us know in the comment section down below. You can also find links to more Coolselector tutorials in the video description below. Do check those out. Once again, thanks for watching.